Alright guys, so today we're going to start with even and odd functions. So, even functions. First of all, I want you to see what they are and what the relationship is with their graph and coordinates in their table. So, we're going to start by filling this table out for both of these functions and then sketching us a graph. So, I'm going to go to get my table just to make it quick. I'm going to plug in my first function, 2x squared minus 3. And get my table. So I'm filling this in from negative 3 to positive 3. So my coordinates are going to be 15, 5, negative 1. 15, 5, negative 1. Negative 3, negative 1, 5, 15. Alright, my second function, I'm going to clear this out and get a table for it. So x to the fourth minus 3x squared. And so my table for this from negative 3 to positive 3 would be 54, 4, negative 2. Then it was 0, negative 2, 4, 54. Alright, so already I'm noticing a pattern in the tables. Okay, so the pattern that I'm noticing is for both of these functions, it says these are even functions. So I'm looking for the relationship between the coordinates in an even function. So negative 3, if I plug that in, I get a positive 15. If I plug in a positive 3, I get a positive 15. Okay, so negative 2, I get 5. Positive 2, I get 5. Negative 1, I get negative 1. And positive 1, I get negative 1. Okay, and then 0 is just by itself there. But the same pattern happens over here. So negative 3, 54. Positive 3, 54. Negative 2, 4, 2, 4. Okay, so I'm noticing that whenever I've got even functions, it looks like no matter what I plug in, if the coordinate I plug in is negative or positive, I'm still going to get the same thing back. Okay? So I'm going to sketch a graph of this right quick because I want you to see what the relationship is graphically. So for this first one, I'm going to graph these points. I'm going to start with 0. So 0, negative 3 would be down here. I'm going to go over to negative 1 first. So negative 1 would be here. Negative 2, 5 would be here, and then 315 would be off my graph, so this side of my graph looks like this. On the right side, when I go over to 1, that's going to go up to negative 1, and then 2 would go up to 5 again, and then 3 would be off the graph. So this is my function there. Okay, so before I look for the pattern, I'm going to go graph the other function. So negative 3, 54, I can't plot. Negative 2, 4, I can, so it goes there. Negative 1, negative 2 would be here. 0, 0 would be here. 1, negative 2 is here. 2, 4 is here. So my function is going to look something like this. Like a W. Okay, and keep going. So now, what I'm noticing about these functions is that they are mirror images of each other over the y-axis. So if I were to draw a dotted line right here, right down the center or right down the y-axis, if I were to fold on that dotted line, so fold the grid in half, my functions are the same on both sides, and that's what accounts for this pattern in the table as well. So even functions, any even function is going to have this relationship. Okay, so over here on the next page, f of negative 2 and f of 2 are the same, okay? So f of negative 2 and f of 2 both on that first function were a 5. So this is for our first function. Okay, on our second function, negative 2 was 4, and positive 2 was also 4. Alright, first function, negative 1. Let's see what they were for negative 1 and 1. So both coordinates were 1, or negative 1. So this is both negative 1. And for our second function, negative 1 and positive 1 were both negative 2. Alright, so you can see that in an even function, the y-coordinates, these are the y-coordinates that we've got, are the same for opposite x-coordinates. Negative 1 and 1 here are opposite, but I get the same thing no matter which one I plug in, okay? So in an even function, the y-coordinates are the same. Now, even functions we saw with the graphs have symmetry with respect to, and this is the way we're going to word that symmetry, that relationship where they flip over the y-axis. We're going to word it with respect to, symmetry with respect to the y-axis. Okay? So now let's look at the relationship that odd functions have. So I'm going to do the exact same thing and plug my functions in to get my table. So my first function is x cubed minus 3x. And so the table that gives me is negative 18, negative 2, 2. And then we had 0. And then negative 2, 2, positive 18. Negative 2, 2, positive 18. Alright, in my second function, I'm going to go plug that in right quick. So that is x and then the absolute value of x. So I'm going to look at the table. So negative 9, negative 4, negative 1. This should be 0. And then 1, 4, 9. So again, I'm looking for a pattern. This time it's different. It's not the same as what the even functions had. So if I look at negative 3 and positive 3, the difference between the y coordinates is that they have one's negative and one's positive. So those are opposite. Okay, same thing with the negative 2 and the positive 2. For negative 2, we get negative 2. For positive 2, we get positive 2. Same thing with the negative 1 and positive 1. Negative 1, we get 2. Positive 1, we get negative 2. Okay, so their signs just switch or are opposite in an odd function. I'm going to sketch the graph so we can hopefully see that relationship and that symmetry. So 0, 0 is here. I'm going to go to the left first. So negative 1 up to 2 is there. Negative 2 down to 2 would be there. So this side of the function looks like that. Okay, the negative 3, negative 18 is not going to fit on there, but it's going to keep going down. The other side, if I go over to 1, that's down at negative 2. Over to 2, I go up to 2. And then 3 goes up to 18, so this side looks like this. Okay. Now, the second function, if I go graph it, negative 3, negative 9 is going to go off. So I'm going to go to negative 2, negative 4. Then negative 1, negative 1. Then 0, 0. Then 1, 1. Then 2, 4. And then 3, 9. So this function is going to look something like this. So now, the relationship in the odd functions is that these functions both go through the origin. Okay, so odd functions will always go through the origin. And if I were to take one side of the function, one side of what's on the origin, and I were to rotate it around the origin, or that point 0, 0. So if I were to rotate that around the origin, okay, and pretend that point's in the same place, then it's going to be the same on both sides of that function when I rotate. Okay? Same thing would happen over here. I could take this part of the graph right here, and I could rotate it down around, and it would match up with this side. So odd functions are going to have symmetry with respect to the origin. So let's look right here. F of negative 2 and f of 2 in the first function. That would be negative 2 and 2. In the second function, negative 2 was negative 4, positive 2 was 4. Alright, same coordinates in the first function, or different coordinates, negative 1 and 1 in the first function. So negative 1 would be 2, positive 1 would be negative 2. In the second function, in the second function, if we did negative 1 and 1, we'd get negative 1 and 1. So you can see that for opposite x coordinates, okay, so for opposite x's right here, I get opposite y's as well. So these are opposite, okay? And then an odd function is going to have symmetry with respect to the origin, okay? So when I think of odd functions, I think odd origin is 0, 0, okay? So it just helps me remember that odd goes with origin because it makes that point 0, 0, which is the origin. Alright, so I want you to understand what an odd and even function is, but I also want you to be able to prove that a function is odd or even with algebra, and you'll need to be able to do this in calculus. So it says all functions are even, odd, neither, or both. There's actually only one function in the whole world that's both, and I'm going to let you try to figure out what that is. But in an even function, we've already said that it has symmetry with respect to the y-axis, and I know that I get the same for -2 or +2, I should get the same y-coordinate, okay? And so the way that you're going to test, and so this is what I want you to do when you're telling me whether a function is even, odd, or neither. You can use your calculator as a check and look at the graph, and the table as a check and look at the table. But what I want you to be able to do is find whether an even or a function is even, odd, or neither by using an algebraic test. And the test is to plug in -x into your function, okay? So x right here, this represents the function. We can think about it for all the positive x's. I want to see what I get when I plug in a negative number for x, okay? So what I'm going to do, anytime we test, I'm going to plug in -x. So -x² plus 3. Now, if I plug in a -x and not a positive x, I should get the same thing back that I started with. So right here, when I simplify this, a -x², when I square that negative, it becomes positive. And when I square x, that's just x². So when I simplify this expression, I get back the same thing that I started with, okay? And we know that we should get the same for even functions. So this is going to be, whenever I get the same thing that I started with, this is an even function, and I want you to also tell me what kind of symmetry it has. So this is, you would say f of x is even, and has, you can abbreviate this, symmetry, or sim, with respect to, and you abbreviate with respect to a lot like that in math, so WRT. So sim, wort, and then y-axis. So I say this is sim, wort, axis. So f of x is even and has symmetry with respect to the y-axis. Alright, let's look at an odd function. So right here, I'm going to do the exact same test, okay? So I'm going to plug in -x everywhere I see an x. Now, in an odd function, we know that we get the opposites. Okay, the opposite coordinates happen in an odd function. So if I get the opposite of what I started with, okay, so this is what you should get whenever you simplify an odd function. A negative on the outside of the parentheses, and then exactly what you start with on the inside. Okay, that would be the opposite of what you started with. So I'm going to simplify this after I plug in -x. Now, when I cube a negative, that's going to stay negative. When I cube the x, that's just going to be x cubed. And then right here, a negative times a negative is going to become a positive. Now, that leaves you with an expression with a negative out front. And we always need to factor out a negative in the front if it's in the very first term. So I'm going to factor the negative out. That'll be positive x cubed. And then that negative, when I factor it out, changes the sign of that x inside. Okay, so I just switched the signs of both of these. So now, I ended up with the opposite of what I started with. So this function is one that is odd. So you would say f of x is odd and has sim, wort, origin. Okay, this has origin symmetry. Okay, and you can see by the graph that if you rotated this around the origin, you would end up with the same thing. Okay. Alright, a neither function. So this one is going to have neither, and you can see by the graph that I can't rotate it around the origin because it doesn't even go through there. And I also can't fold it over the y-axis and it be the same on both sides right here. Okay, I wouldn't be able to fold that over and it be the same. So this is going to be neither, but let's see why when we do the test. So if I plug in -x² plus 4 times -x plus 4, and I simplify this, a -x² is just going to become a positive x². 4 times -x is a minus 4x, and then that plus 4 doesn't change. I definitely don't end up with the same thing as what I started with because that sign is not the same. I also don't end up with a negative of what I started with because there's no negative that I could factor out of the front of that. So then this one is one that is neither. So you would say f of x is neither and has no symmetry. Alright, so let's look at 8 different types of examples. So we'll start out Easy. Number 1. Okay, determine if the following functions are even, odd, and neither. I also want you to tell me what kind of symmetry the function has. So I'm going to start by doing exactly what I did here. You can use your calculator, like I said, as a check, but you really need to be able to test for even, odd symmetry, okay, without the calculator. So, especially when you get to calculus. So we're going to go ahead and plug in negative x for my test. And so then, anytime you raise a negative to an even exponent, anytime you raise to an even exponent, that's basically just going to take your negative and make it positive. Okay, because if you were to multiply all of those out, a negative times 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 a negative, you would end up seeing that whatever you got would be positive. So this is going to end up being x to the 6, plus this is going to end up being a positive x to the 4th, because I'm raising it to an even power. And then right here, this minus stays. That minus stays because it's not being squared. That's not the negative that's being squared. This one is. So this negative is going to end up becoming positive, and I'll have an x squared. So I ended up with exactly what I started with. And so this tells me that f of x is even and has symmetry with respect to the y-axis. Alright, number 2. I'm going to do the same thing. Negative x goes in for that first x, and then negative x goes in for the absolute values. So, right here, whenever I have an absolute value of a negative, the absolute value kind of just takes that x and makes it positive. Okay, so I know I've got absolute value of x there. And then I can't really do anything with that x out front, so I'm just going to leave it like that. Now, this right here, what I've got, is like having a negative 1x. And so, because that's the case, I can write it like this. I can write it as a negative, that's like a negative 1 on that parentheses, and then x times absolute value of x. And if I were to multiply that negative to this function, if I were to get rid of the parentheses, I can't give the negative to something inside the absolute value, so the negative would just go to this x. And so I would end up with what I have here. And so since I can write it in this form, this is going to be the opposite of what I started with. So that would mean f of x is odd and has symmetry, or sim, with respect to where origin. Okay, so it has origin symmetry. Alright, number 3. My exponents are kind of high, but these are both exponents on the x there. So, number 3, I'm going to go ahead and test. So, do the same thing. I'm going to plug in a negative x squared. And then in the bottom, I'm going to have 1 minus a negative x, and that's squared. That squared goes with that. Okay, so when I simplify this, a negative x squared is just going to be a positive x squared in the top. In the bottom, a 1 minus. Remember, this minus doesn't go anywhere because it's not being squared. And so the second minus is going to go away and just leave me with x squared. And since I end up with what I started with, that means f of x is even and has sim, wert, y-axis. Okay, so symmetry with respect to the y-axis. Alright, number 4. If you're watching this, I would pause me and try this one, but I'm going to go ahead and do it. So we get 2 times negative x to the 7th. I'm plugging in my negative x so I can test, see if it's even, odd, or neither. Then minus 3, negative x to the 5th, minus a negative x squared plus 1. Alright, so whenever I simplify this, just like whenever we had even exponents right here, it made it positive. Whenever you have odd exponents, that's going to keep it negative. Okay, so an odd exponent of 7 would keep that x negative. And so this would end up being a negative 2x to the 7th. Okay? Now, the middle term, that's a negative, or that's a odd exponent as well. So this is going to end up being, this negative nothing happens to it. It doesn't go anywhere. That's not being raised. So minus 3 And then when I have a negative x to the fifth, that's going to stay negative x. So that second negative that I have is going to come make this a plus 3x to the fifth. Now right here, this negative stays for now, but when I square this negative x, it's going to go away, so it'll leave me with that, plus 1. Now we've got a negative in the front, so I need to factor it out. So 2x to the 7th minus 3x to the 5th plus x squared minus 1. So then I've got the opposite of, do I have what I started with? On this one, I don't, because that sign is different and that sign is different. So since my signs are different and I don't have exactly the opposite of what I started with, I'm going to say f of x is neither and has no symmetry. Alright, 3 more examples. Number 5. So number 5, I'm going to plug in a negative x to the bottom. That's all I can do. This is like a negative 1, so when I simplify 3 divided by negative 1, that's just going to end up being a negative 3x, which is also the same as this. So since I end up with the opposite of what I started with, f of x is odd and has symmetry with respect to origin. Okay, before we do number 6, I want to just go over a little bit on how we multiply fractions. Alright, so when we multiply fractions, let's just look at an easy one. Let's do 2 times 2/3. Okay, if I did 2 times 2/3, I'm going to do that in the calculator so you can see what that's going to be. So 2 times 2 over 3. I'm going to change it to a fraction. And so you can see that the only number that we multiplied that 2 by was the other 2 in the top. So that would give me 4/3. And the reason that it happens like that is because this is like a 2 over 1. And when we multiply fractions, we multiply straight across. Hopefully this will help you understand what number 6 is going to be. Okay, so when we multiply fractions, we multiply straight across. So whenever I do this, if I were to end up with an even function, I would need the exact same thing with what I started with. If I were to end up with an odd function, I would need to be able to write my function like this. Okay, so if it were to be odd, I would need this. Okay, so I'm just going to keep that in the back of my mind while I do my test. So I'm going to plug in negative x plus 3 over a negative x minus 4. So this is going to end up being negative x plus 3 over a negative x minus 4. And when I factor out, I've got to factor out a negative before I can cancel them. A lot of people at this point will want to go ahead and cancel out these negatives. And you cannot do that. You have to pull the negative out before you can cancel them. So I'm going to pull the negative x, or the negative out, and that'll leave me with x minus 3 divided by a negative. This will leave me with an x plus 4. And so now these are like negative 1s that can cancel out. So this is what I end up with. Now, everybody can see that that's definitely not what I started with, so it's not even. But it's also not odd, and a lot of people will think that this is odd. They will think that this is the opposite of what they started with. It's actually not, okay? And the reason is because if it were to be odd, this is what I would need to have. So I'm going to take this over to the next page, and I'm just going to copy it, and work out what we would have if this were to be odd. So if it were to be odd, we said we would need this. Okay, and this is like a negative 1 out front. Now, I'm going to do the same thing as what I did here and stick that over 1. So, in the top, if this function were to be odd, this is what I would need to have. The negative 1 distributes to the top, so that would be negative x minus 3. Over 1 times the bottom is just x minus 4. So, this is what the opposite of what I started with would look like. you can see that we're missing a negative in front of this x right here. So we do not, even though it looks like it, even though these two signs are opposite, this is still not the opposite of what I started with. So this is not going to be an odd function. So you would say f of x is neither and has no symmetry. And we're going to do another one like that in just a second. Okay, so number 7, last two. I'm going to plug in a negative x. I'm testing this to see if it's even or odd, or neither. So I'm going to plug in my negative x. And so when I plug that in, this is going to end up giving me just a negative x on top. I can't really do anything with that. And in the bottom, I'm going to end up with that cube leaves that x negative. So this is going to be a negative 2x to the third. And then, I forgot my negative there. So then this one, negative 3 times a negative x is going to be a positive 3x. So now, from the bottom, there's a negative in the front. I cannot go ahead and cancel them right here. I have to factor the negative out of the bottom in order for me to cancel the negatives. So this is what I have when I factor it out. A 2x cubed minus 3x. So then my negatives will cancel, and I'll be left with an x over 2x cubed minus 3x, which you can see is the exact same thing as what I started with. So then that is going to end up being an even function, so you would say f of x is even. And has symmetry with respect to the y-axis or y-axis. Alright, so that's that one. Now, number 8 is similar to this number 6 that we did right here, okay? So number 8, again, I'm going to test. So I'm going to say 3 negative x plus 4 over negative x. Now, when I do this, this is going to end up being a negative 3x plus 4 divided by negative x. And so we've got a negative in the top. I have to factor it out in order to be able to cancel that negative. So I've got this. And so now that I've factored it out, the negatives can cancel, and I'm left with 3x minus 4 over x. Now, a lot of people think that's the opposite of what we started with. But think about what the opposite of what you started with would actually be. Okay, so I'm going to take this function, 3x plus 4 over x. And if I had the opposite, I would have to be able to write it like that. Now again, if I were to work that out, remember that negative only gets distributed to the top. So this would be 3x, negative 3x minus 4 over x. And this would be the opposite. And so, since we do not have that extra negative that we need right here, this is not the opposite. So this is going to be neither. So you would say f of x is neither and no symmetry. Okay? And that's all we are going to do with even and odd function. There's some more problems that we could look at, but we're going to stop there.